learning. Classical machine learning, fine. Same way, when you are started hearing about quantum computer, immediately you will started thinking that okay, if we apply QML, it will be great. You might thought about it in such a way, right? Then why it is not working? Anybody tried working with it? No, right? So you know the North Indian and South Indian problem, you know, right? North Indian knows only Hindi. If South Indian goes there and he works, what will happen? In the first 3, 4, 5, 6 months, South Indian typically don't know Hindi. I am talking about that South Indian. So what will happen? No, even I lost. I was working in Galgottia's University 2018. First I was got down in Greater Noida. I was seeking auto. I have given 200 rupees. He given me back 50 or something like that. I don't know how much he charged, I don't know. How much charged, I don't know, and I don't know how much I need to get back. Whatever he have provided, I have took it into my pocket. Later only come to know it is 50 rupees only. He charged me 150. He charged me 150. Right. There is a connectivity between these two statements, right? You are interested in QML, and now we are in what? We are in classical, right? What is the problem? Tell me. Classical is South Indian. Classical is South Indian. And the quantum machine learning is North Indian. Now you tell me what we can do possibly. Please keep it. Yeah. எது கொடுத்தாலும் சாப்பிடுவேன். Right. QML. Actually it is not QML. Quantum inspired machine learning. There is no terminology called what? Quantum machine learning. There is a paper in earlier 2012 something. Peter Wittek, the first gentleman who proposed this is what? Peter Wittek in Montreal, Quebec. There is a conference placed in Montreal, Quebec. There is a paper what? Quantum inspired machine learning. That is the first arrival of what? QIML. It is not QML, QIML. Right. What is the first challenge we are having? First bottleneck or challenge. There is no quantum random access memory. There is no quantum random access memory. You know Jupyter Lab. How to work with Jupyter Lab? Having uploaded data set from external environment, what is the procedure? Tell me. There is a problem. We cannot upload any data sets, there is a memory restriction. Even in classical, we cannot upload data sets just like that and we cannot able to run. Yes or no? The same problem. Jupyter notebook only we have to use for QML also. There is also what is to be done. Data set is picked from outside and put it into the environment. From there only we need to run. Either we need to pick it directly .csv, we need to provide URL, we have to run. So who is responsible? For classical computer, random access memory is responsible. So there is no quantum random access memory. That is the first bottleneck we are having still now. We are having bottleneck. The first bottleneck is what? There is no quantum random access memory. It is also small problem only. But which is the biggest problem? Tell me.
Storing bits.
Storing bits. Somehow you are closer. Read it. What is QML? It is a paper proposed by Peter Wittek. So quantum inspired machine learning. Classical. So classical we are all experts. We provide whichever application we work, 100% accuracy will be there. If we project your confusion matrix, it leans. Right side two corners, you claim 100% accuracy, I know. Whereas there is error which is having 0.991, you will never get what? It is not your actual 100. It is manipulated 100 to be honest. It is manipulated 100. Super. Right. So that is classical ML. So again we will get back. Suppose there is a data set its accuracy is above 95. So that only we can try to work in QML. Already in classical the value is ranges 8, 8.5, it will not provide good. QML will give less than 10. QML will give less than 10% of classical. Why? We are having 4th generation hardware we are having. What we are having? 4th generation. 40 years we are having the classical hardware. What about quantum hardware? Now we are using 1st generation only. It is like a baby. Now it is in a baby step and we are not having proper access. If you want to have the quantum advantage, how much qubits we need? 100 qubits. How much we need? This is a second bottleneck. Nobody have exposed to what? Run those in actual quantum hardware. We don't have access what? To run on an actual quantum. We can simulate. Still what we are doing? We are simulating. See why? So this is our statement. Okay, this. Okay, no problem. எப்படி இருந்தாலும் குடிச்சிடலாம். நம்மளுக்கு தான் அது. Look at here. What is the clue in quantum? Entanglement. And in which part of classical ML we are putting into what? Entanglement in QML. It is not possible to put everything like that. There should be a specific converted algorithm. There is a fashion before 2-3 years. Classical SVM is there, QSVM. NN is there, QNN. No, it is not like that. It is not possible first. Why? Come back to the North Indian and South Indian problem. What I am to convey? Look at this diagram. Look at this diagram and tell me exactly where we are. I am giving this challenge to the computer science department. Computer science department have to provide me the answer where we are exactly.
We are in QC, sir.
We are in QC, wrong. We are in CQ era. C, whereas the first CC stands for first compartment data. We are having, sorry, hardware. Classical, first is classical hardware and classical data. CQ means classical data, quantum hardware only we are having. Right now we do not have any quantum data. Whichever classical we are having should be converted into quantum. How to do that? ஏன் இப்போ உங்களுக்கு விடிய இந்த முன்னாடி கதைலாம் சொல்லி கொடுத்தல? Why I have taught all those stuff? Tell me how to do that. அதுக்கு தான் இவ்வளோ பெரிய மேத்தமெட்டிக்ஸ்லாம் எடுத்துக்கொண்டது உங்களுக்கு கடைசி வரைக்கும் இங்கே I brought you till this. How to do that? Tell me. Yeah. So it is not possible. The fourth quadrant is what? Running actual quantum data over the quantum hardware. Maybe in another 10 years. Maybe in. So I tried 100 GB. We are trying to decode a quantum data. It is 100 GB. CloudStar. There is a website called CloudStar. There you can see quantum data is available. 100 GB. HPC, you know HPC, right? HPC's output will be ranges from 100 GB. It is not possible to put it into Jupyter notebook environment. Is not at all possible. What is possible? We need to do PCA. For that we pick a portion to 100 MB. That we need to PC. That results only we can work actually as an academician. If you are from IIT Madras, we can run on what? Real hardware. They have subscription. They have. So we depend on simulator. So what is the? We are living in which era? Classical data running over quantum simulator, CQ era. So that is the third bottleneck. Where we are actually, the third bottleneck is what? Classical data should be converted into quantum states. Converted to quantum state. So Maria Skuld Franz Peterson. So there is a book called Machine Learning with Quantum Computers, written by Maria Schuld and Francisco. This picture I took it from there only. I do not have that idea. I am not that expert. It is Maria's representation. So we are asking what? Classical data trying to run in quantum hardware. That is what our idea, right? Whichever problem we are having, we put it into quantum, it will give better results. No. We need to find appropriate encoding methods. We need to find what? Encoding methods. Process of converting classical data into quantum data. So it is trial and error only. Now if I ask you which method is good for a text data set, is it possible? Only after trial and error we will come to know what the accuracy. Same in QML also the same process. It may converge or it may not converge. But one thing we have seen, 1/3 the training time is elapsed. In quantum, what is very good? Instead of accuracy, training time 1/3 is minimized. If it takes 100 seconds, it takes only 30 seconds. In quantum, while training, what is the magic? Training time 1/3 is reduced. Any data set, if you provide, what is happening? The training time is drastically reduced. That is possible. Any data set you provide, it will give 60% accuracy. It will give only 60. So then we need to do all the things. We can able to 70, 75, 80. The thing is what? North Indian, South Indian should be converted. There is intermediate or what? It should be converted by encoding schemes. Right. Classical data, quantum, hardware, CQ era. The problem QRAM, what is possible? Encoding, future map. So what do you mean by future map? What do you mean by future map? Any idea? No. Then some people are saying working in machine learning. What is future map? It is very simple. It is not a high-end thing. Projection space, higher, super, higher dimension projection is what? Future. Whichever we are having in the lower dimension projected to the higher dimension is what? Feature map. Extracting or measuring the output. Various quantum machine learning algorithm. Let me read it out. QSVM, QNN, QKNN, QRF, QLSTM, QPCA, QGAN, quantum clustering, quantum autoencoder, VQC. This semi-supervised, unsupervised and supervised. Right. So there are theoretical algorithms are there. There are 10. There is 10. But as of now, promisingly, classifiers are working well. In quantum, classification is working fantastic. Prediction is tough. Prediction is tough. I didn't say it is not possible. Predicting process is tough. So classification, it will do magics. Support vector classifier, or else we can say QS, VM works fine. There is a last component, VQC. I think everybody is now interested in neural networks, right? The alternate for quantum is what? Variational quantum circuit. Every neurons will be a parametrized circuit is what our VQC. So please note it down. QSVC, various kernel function, quantum kernel function. VQC, variational quantum circuits. So these methods are providing some good results. QSVC, quantum support vector classifier, or QSVM, quantum support vector machine or quantum support vector classifier. Various quantum kernel methods, quantum kernel. So kernel is only what it does, projecting the lower into higher dimension space. What it does, that is the beauty of kernel trick. What is kernel trick in classical ML? Suppose we are not classifying linear, non-linear SVM, especially non-linear SVM, we need to go for projecting using kernels. So that is what. In quantum, what is advantage? Quantum kernels are very effective. Quantum kernels are very, out of all, there is one out of thing compound, reservoir computing. Whenever somebody talks about advanced quantum machine learning is reservoir computing. I have not explored, but I have came across. There is a terminology called reservoir computing. So that is one promising quantum technique. See, quantum support vector machine. So in this, which part is put it into superposition? Take a look. So for every quantum algorithm there is subroutine. Those subroutines only put it into superposition, or else we can say entanglement. Look at there. In QSM, which part is put it into? Groover's optimization. Only what? That's the beauty for QSVC or QSVCM. We are putting the part of Groover's search optimization part into entanglement. Working procedure of QSVM. Then algorithm. This is the algorithmic working of. See, look at here. Whenever we talk, what comes? Kernel function comes into picture. So we are dependent on kernels. We are dependent on quantum kernels. We are dependent on quantum kernel. Representation of classical data and parameters is quantum states. Look at here. What is second? We need to convert or prepare the classical data into quantum states. So inside bracket encoding. Inside bracket it is technically encoding. Then subroutine. Superposition of all possible institute. Global minimum for SVM optimization. So that is what the major process takes place at what? Subroutine putting all possible into global minimum. What is global minimum? In classical, what is global minimum? Global maximum, local minimum, local maximum. Right. So let us move one step. QPCA, we don't want to go too much into QPCA. It's very complex. Please note it down. Quantum algorithms and their applications. Various quantum algorithm and QML algorithm. HHL, Harrow, Hasidam, Lloyd. Applications QSVM, linear regression, QPCA. Needs what? It needs HLL. Groover's. QK means median, QKN and all depends on Groover's algorithm. Quantum phase estimation, QK means, quantum K means variational quantum circuits. Reinforcement learning, neural networks and all handled by parameterized quantum circuits or variational quantum circuits. Each neuron will be replaced by parameterized quantum circuit, VQC. So in this area only we worked. We simulated to depth 2 and 4. We published a conference paper in 2022. It have 11 or 12 citations for this VQC. Directly we jumped into prediction. We don't know anything. We straight away jumped into, see now the quantum machine learning knowledge is different. By 2020 we straight away jumped into prediction, but it is tough to predict. We increase the depth to 1 step. We reach depth 4 and there is a small convergence. Right. Softwares for QML. So using this we can use Qiskit, Cirq, Penny and QShop. We can work in quantum machine learning, which is simple. Penny is simple in documentation. and execution. Simple in execution and documentation. Look at, so this is the process, how to carry out in stepwise. Setting up the environment, loading the data set from the repository, pre-processed data set, normalizing, converting classical data to quantum. நீங்களாம் ஹாப்பியாக இருப்பீங்க. அங்கேயும் உங்களுக்கு there is a checkpoint, encoding இருக்கு இல்லையா, அங்கேயும் என்ன இருக்குது, there is mathematical representation, basis encoding, qubit encoding, amplitude encoding, FRQI, there are encodings and their mathematical representation. அது புரிஞ்சாதான் அது how it works புரியும். இங்கே என்ன வேணாலும் பிபிடியில் காமிச்சிடலாம், but how it works, that equivalence, that next parameter circuit, then training the circuit, finally decoding or measurement, finally decoding or measurement, right, encoding. So process of converting classical data into quantum data. So we are putting conventional or classical data into quantum machine as quantum states. Then only possible to what quantum computer will learn through training. How quantum computer learns? Only possible of what quantum state. Apart from quantum state, it does not know anything. So whatever it is given to it, it should be a quantum state. Various encoding techniques: basis encoding, amplitude encoding, basis, amplitude, angle, QRAM encoding, FRQI, and so on. Let's see one by one. Time evolution, flexible, FRQI. Right. So this is, so is it visible till last? Look at that. Depending on the problem statement, we choose encoding. Basis encoding is represented by what? Whichever it is there, it will be converted into corresponding quantum state. So we are having 2, right? What is the number for 2? 1 0. B0, B1 is what? 1 0. And look at the difference. What is this? State. Classical is converted into quantum state. It is present inside ket. Whenever something is put into kets, it will be considered as quantum state. It is very simple, and theoretical encoding is what? Basis encoding. Example xi is 2 3 1 0 2 and 1 1 2. X is what? The vector 1 0 1 1. It requires more qubits. It requires basis encodes needs what? More qubits. See why I am present like this? Because of this animation effect, I present in its as it is. Amplitude encoding. So the next encoding type is what? Amplitude. It is called wave function encoding. The angle difference between the states will be what? Recorded. Normalized classical data into state amplitudes. X is converted into amplitudes. Example. Example for x equal to x1 to x2 imply what is psi x? What is psi x? What is psi x? What is psi? Superposition. superposition, right? Quantum state superposition or what? Whatever value we are having, we are putting into quantum state. If you work it out further, what is it? What is the value? 1 divided by root 2 square, 1 square. What is the value available inside this? Two 103. So what is how to work it out? 2 square, 1 square, 0 square, 3 square. Then it is converted to, and then what is that? This is the remaining state. 2 of 0 0, 1 of 0 1, 0 of 1 0, 3 of 1 1. It also requires more qubits, not widely used. Amplitude encoding. Next, angle encoding. So there is another technique called angle encoding. So here only what? Difference between the states is what? Entangled qubits is noted. It is otherwise called qubit encoding. It is otherwise called qubit encoding. So how to work it out? So qubit means what comes into picture always? Tensor comes into picture. Tensor. This is tensor, right? X is having rotations pi, all pi. Then what? Now it rotates every qubit around which axis? If you are giving in x, it will be rotated around y. If it is y is given, it will be rotated in z. So that is example for angle encoding. So Kandipa, you might be thinking, so QML, we might not be asked QML. QML is also little bit tricky. Time evolution encoding. So another encoding. This is little bit familiar. Time encoding, FRQI is what used in the most of the applications. Time evolution, do you have any guess? What is a task preferred for time evolution? Prediction. Time evolution is required for which type? Prediction type. So it will be a little bit challenging, yeah, prediction. To associate scalar x belongs to R is what? Scalar. So one example workout for how time evolution works. How time evolution works. Psi of what? E power minus x h. X value is what? Minus 0.0438. Psi, and we are putting the value of x into bracket minus 4.38. Cos of minus 4.38 of state 0. Sin of minus 72 divided by 2. Why it is divided by 2? We are taking amplitude, yeah. So we are dividing by 2. Approximately what is the value? 0.976 for 0 and 0.217 for 1. So in this way what works? Time evolution encoding works. And we are always interested in neural networks, right? What is a targeted output of neural networks? Classification. Classification of image. Classification of, there is a problem in handling image data set in quantum. Why? I told you, in environment we should not put the entire data, is not possible. Only a particular, we need to apply PCA. We need to apply PCA, then that input will be given to the variational quantum circuit. Then what? Which is to be done? FRQI. It's a dedicated encoding method used to what? Handle images for quantum. Whenever we are converting classical image into quantum, right, this encoding is widely used. FRQI, flexible representation of quantum images, right. There is one problem in classical. There is only one value will be there in classical image. But what about the beauty of quantum? It have two values. One is for pixel, the other one is for the depth. So that is why it is what? It does little bit smarter than our NN. So it captures pixel and position. Image will be captured using n plus 1 qubits. 1 qubit for pixel position, another qubit for grayscale intensity. 1 pixel position for and another qubit for grayscale. So what is it? Again we are having multiple options, trial and error encoding, then training, finding out the accuracy. If not works well, repeat in alternating way, then only we will end up with. It is more time consuming than classical. What is the first condition? That data should yield 9 in classical. Those only will be used for. If it is not good in classical, that is never ever used for quantum. Why? It will give lesser than that. It will give definitely lesser than that. And one more thing, we are paper tigers, we are paper tigers. I didn't excluded myself. We are paper tigers, right? Why there is not much quantum machine learning papers? Did you ever noted? Why? There is one more parameter. For every output in quantum computer, there must be a valid quantum circuit. What is that? For every output, not only quantum machine learning. For every output in quantum computing, there must be a quantum circuit. That circuit is responsible for that output. So that is the reason what is not possible. Who is handling quantum machine learning topics, they know which is valid output, which is not valid. If there is a valid circuit, okay, they have done something. There will be circuit. Future maps. What is it? Sequence of quantum gates. So we have seen so many gates, right? So that will be shown in matplotlib. If you show, it will show what are all the gates used for that particular task. Either classification or prediction is done using there is two future maps, Z future map, Z future map. There are two ZZ and only Z. CZ, two future maps are available. What it does? Converts data into lower dimension into, see, in general, if you represent anything in the quantum, it is in higher dimension. It is always in higher. But classical is not by default, it is higher. If we specifically convert, it will goes into higher. It will be only higher. But in quantum, generally it is higher dimension only, because quantum kernel. What is there internally? There is quantum kernel. Right. So at the end, FRQA, take a note it down this. Basic encoding gives advantages for which one? Over binary data set. Basis encoding give advantage over binary data set. Amplitude, image data sets. Angle, periodic functions are symmetric. FRQI is also image. Healthcare, right? If you are using healthcare, you can try first FRQI. Try FRQing encoding, then you try with the remaining. Right. So this is a typical steps. Anaconda website, download, install suitable. And there is one more thing. So how you are running your codes now? Quiskit. Jupyter notebook. Why? Okay, fine. But it will not be fine, I think, now. Where to run, how to run? So there is a cloud called Kubernetes. There is a cloud platform to run any quantum code we are having. Kubernetes. By default, Qiskit is provided. Inside Kubernetes, what is given? By default, Qiskit. If you are having paid subscription, we can run multiple. Penilon will be run under Kubernetes or Circ. So there is option, only we need to click. There is option, only we need to click. See, let me show you one quantum circuit, then only you will be happy. Professor Tamil Nadu vandaru, ennathe kaamichittu poitaru. You should not say like that. I will show you one. Let me show you quantum circuit. So before that, I will show you dummy code. Right, look at here. How to work with Python? How to work with Python? I think we are all experts in Python. How to install packages? If outside of the thing is there. What is the command? Pip, PIP. So what are all the necessary packages for classical machine learning? Scikit, Pandas, NumPy, Matplotlib is not required. It is there inside what? Super. So by using same way we need to install either QuizKit, pip install PennyLane, pip install QuizKit. For machine learning, pip install QuizKit underscore machine underscore learning to be given for what? To run codes locally. To run. So we need to replace by what? Right. So this is a sample code for tie classification problem. Look at here. Various imports. Import PennyLane. So if it is successfully imported and it is available in local repository, you can access the instance of what that. Now I have given it as QML. Now I have given it as QML. Which dataset I am trying to use? I am trying to use datasets from sklearn. Super. These are all straightforward, simple. Which code? Classical code. Right. How to identify in this code which part is from QML? Look at this instance. This is not Q, right? Why? What is the instance we have given for this? Whichever function we are invoking with the help of QML, that only what? That is quantum machine learning part. Look at here. QML dot device is a line responsible for what? How many qubits are available? It will take default. We have provided in between single codes, wires to 2 lines for every qubit. How many lines will be there? 2. Why? Inge nambalukku nammaloda saayam veluthurum illaya. Our colors will come to know. What is that? See, always QC. Q is for what? If there is a circuit, quantum, and C is for classical. That's why 2 lines. A qubit will be provided with single line for quantum. Whatever it is there, that should be measured using your classical quantum circuit. Whatever we do, where is the output will come? Through your quantum circuit. Through your quantum circuit. Depth circuit. Depth circuit. QML dot Rx Ry. What is Rx Ry? So gate, rotation gate X, rotation gate Y. See, my chief executive officer and we frequently discuss. In a college, in fashion, they ask to deliver QML on the first day, first session. How it will be, you tell. My CEO and we will laugh. After the organizer will speak to us, right? First day we want to deliver QML. We both will laugh always. QML will be taught at the last session. They don't know what is quantum state, they don't know qubit, straight away they jump into QML. No, it is not possible. It is not possible. It is not. So there are so many procedures and protocols, right? So always QML last session in FDP. We are not to educate organizers. They are big shots and they are experts. We are humble. We will react. We don't know. Yes, we will do. Yeah, fine. Right. For I range C0. Why we are using C0? So there is a code. Now you will understand C0 is what? The purpose. It is entangled. There we are putting what? Entangled qubits using C0. So if I provide the code, at least you will able to something is happening there, right? Pip install Y. What will happen? It is not possible to what? Visualize. So before that, install torch vision, torch audio. So this code is running locally in Jupyter Notebook Pennylen. It is not cloud. This code I fetched from where? Local or inside the prediction circuit. Look at here. From circuit only what? We can predict back propagation. What is the purpose of back propagation in classical? Last or backward optimizer. Epoch loss plus item. Plot predictions, plot label. Confusion matrix, heat map. Sample code QML from Pennylen. Sample code of QML from Pennylen. Still we have not seen any circuit. This is only valid output. I will show you circuit. Right. Cube right. Let me run from the beginning. So it is a cloud platform. So this code I have ran on December 7, 2024 for showing this to FDP people. Pennylen classification toy problem. Right. So pip install pandas, pip install num5, pip install upgrade pip. So I will show you the first the future map. That is the place where what? Yeah, this is that. Look at here. What is that? H. What is H? Your P. Cell quantum gates. It is purely works in your quantum only. We can't do anything with your classical ML. So this is the person who is responsible for what? Validating a quantum machine learning output. Future map. This is what? Future map. Detailed future map dot draw. If it is there in your result, you can able to write a quantum machine learning paper. We can write a quantum machine learning. And what about classification metrics? And there they come to know, quantum machine learning, or what are all the classification metrics required for quantum machine learning. So just we will discuss what are all the classification metrics for classical machine learning. Accuracy, F1 score, precision, recall, then so these are all versus number of samples. Accuracy for number of samples, all are versus, plotted versus your number of samples. There is three more thing. K statistics. There is a parameter called K statistics. K informedness. There is a parameter called informedness. So these are all especially needed for what? Quantum machine learning classification. K statistics, informedness. Confusion matrix should show a prompt accuracy and corresponding false negative value. It is not manipulated. 100, there is 1. It will not be 100. Confusion matrix should be plotted genuinely. Plotted genuinely. As usual procedure, what is the first step? Required packages should be installed. Pip install numpy, pip install quizkit. Then after quizkit only what is possible? This is the instance to be called for what? QuizKit underscore machine underscore learning package responsible or contains all functions of quantum machine learning, encoding, and what else there in QML? Future map Z set, Z future map, etc. When we are having that instance, we are able to invoke what? Pandas SPD. I am trying to read from customer data CSV. So there is customer data CSV is here. Customer data. See, I am trying to read from this file. From here only, what is this? QuizKit circuit library, Z set future map. So series of gates manipulating your quantum machine learning results. Z future map, future dimension and reps. Map dot decompose QS, which is what we have used, quantum support vector classifier. Quantum support vector classifier. Accuracy, AUC, KS, I told you KS statistics. Precision, accuracy, AUC, KS statistics is the values required for QML. See, it's simple as classical machine learning. Where is the trick comes? Encoding, future map, then remaining the process is going to be. And what is another important thing? Classically, it should be proven. It should have 100, 99, 98 result is there for the data set that you can try to work with. First clue is what? Training time will be elapsed, 1/3 will be there. So definitely what is that? You have successfully converted into what? Quantum states. That is one proof. That is one proof. Right. So this is one simple sample code for QML. QBraid, where I am running all these steps in QBraid. Let me run from the beginning. So in cloud you can run all your quantum computing codes. So it is running through my mobile's internet. Okay, let it run. So I think you are waiting for one more thing. Let us just we will see the glimpse of the quantum machine learning applications. Right, IBM and HSB, they works together for what? Effective risk classification, fraud detection, consumer behavior modeling. Quantum machine learning can improve the predictive models using HSBC and IBM created quantum kernel. They have created hybrid method of combining several quantum kernels into one. It works very well. IBM and HSBC Bank. IonQ and Hyundai, self autonomous cars they are working. successfully classified 43 signboards. What they have done, IonQ Quantum and Hyundai did what? Image classification and 3D object detections. Together they done what? Improved computational through QML, encoding images into quantum states, 43 types of road signs classified. So it is a big breakthrough in autonomous vehicles. IonQ and Hyundai. D-wave and optimization. We are talking about optimization. It is shipping logistic. Pier 300. There is Port Los Angeles is the biggest port available in the world. In US, Port Los Angeles. How much they are minimized? Let me tell you how much. They are handling how much? 1 million cargo handling scenarios. See cranes, what is the problem? Cranes to fit trucks. There is cranes, with the help of cranes they need to load the trucks. It is impossible to find what trucks for individual cranes. That is a problem with the Pier 300. 7TEX application called 7TEX. They replace the Pier 300. 7TEX works effectively. They are saving in billions. 7TEX created hyper optimized nodal efficiency engine, HON, simulation of Pier 300. Crane operating efficiency was one of the most notable development. So who did? D-wave optimizations and 7TEX. One real time very successful application. IBM and Moderna. IBM works with, what is it? Moderna is known for what? Vaccine. So they have minimized the timing of what? The prediction, molecule prediction with the help of quantum computer. Quantum eigen solver. The algorithm name is quantum eigen solver. IBM with Moderna. Study focused mRNA sequence up to 60 nucleotides in length, representing problems within the range of 10 to 80 qubits. Below 100 qubit they have done this. 10 to 80. Electronics. How many of them is from here? Electronics. Electronics. What is the advancement in electronics? Especially materials. You hear QLED, there is quantum LED is there. One step ahead is there, OLED. OLED is the latest material. Along with IBM, JSR, Japanese rubber chemical company, they developed OLED. They developed just 1% increase in the OLED display market worth 320 billion per year. How much revenue they have generated? 320 billion. See, these all from official documentation of IBM Quantum. I am not just like that delivering. These are all I prepared from quantum chemistry. I was waiting for this slide only. Quantum chemistry. Yes. Being agriculture capital to the world, what is the problem we are facing? Fertilizer. What is the price of 50 kg ammonia fertilizer without subsidy? 5,000 or 10,000? Huh? What is the process? What is the problem? We need to convert what into what? Nitrogen should be converted into ammonia with the effective catalyst. We will have a effective fertilizer, cost effective fertilizer. First challenging chemistry problem is what? We need to find a catalyst which converts nitrogen to ammonia. That is the first chemistry problem. Second is very Superman. We are looking for a Superman. We are expecting a superconducting material at room temperature. What chemistry people looking? Looking for superconducting material at room temperature. So what is possible? Transmission without loss is possible. Last, very superficial. We are having enormous amount of carbon dioxide in the atmosphere. We are looking for a extraordinary material which absorbs it. Once we are able to absorb the CO2 emission, so what will happen? The emissions levels will go enormously down. Our atmosphere will become what? Healthier. So these are all the three. There are many, but these are all the three. It helps global warming. Carbon dioxide absorbing material they are actually looking. So these are all the famous problem statements for quantum chemistry. Nitrogen to ammonia, room temperature superconducting material, and CO2 absorption, right? So this I referred from, it is very much important. QML unlocked by Javier Mansilla, programming quantum computers by Eric G. Johnston, quantum decade. These are all case studies which is available in that specific book, Quantum Decade, IBM Foundation. So we are having access to that. So from there I picked and put it into the slides, right? My team members, Dr. JV, CEO, Ashwath Babu, CTO, Jinesh, and what? So that's it. So I have materials, but I want to stop here. I don't want to move further. Let us stop here. So look at the slides number only 35. I don't have any PPTs above 50, 40, 35, 28. All right. So let me conclude, and I want to, if there is anything, do let me know. You have any doubts? See, don't. I will give one. Don't take quantum machine learning problems for PhD. There are so many issues are there. There is no proper guides are there. Guide is how much year old? 10-year-old technology. He is 10-year-old technology. He must be 10 year ahead. No, it is not. Thesis. Who will evaluate your quantum machine learning thesis? Your professor. Professor is how much old? IIT professor will not evaluate your thesis. He will never turn back. He will never. So there are so many challenges are in quantum machine learning research. So do students activity, blah blah and all. Don't go for PhD level. My suggestion. It is not universal. It is my suggestion. Yeah. Yes, yes.
Recently in your company, what you are doing regarding to quantum?
We do not have any products. We are creating only quantum workforce. No, there are some works. It is in pipeline, but we don't have any products right now. Only we are doing quantum workforce across India. And we reached Nepal also. We have delivered one Kathmandu University. We delivered once in Kathmandu University. We are started delivering Patna, NIT Warangal, and so reputed institutes. We used to deliver only reputed. We won't go just like that. No, we have so many restrictions. It is very difficult to travel. First of all, we have funds, but it is very difficult to travel. We need to sacrifice. My family members are asking, what you people are doing? You people are always talking quantum. What is that? There is nothing. They never seen anything that. No, you people also will face that difficult. Even if I am facing, definitely you are saying that you are doing something in quantum. Nobody will encourage. They will laugh at you first. They will laugh at you first. See, work in optimization. See, simple way to be persistent quantum is work with optimization problem. Optimization, NP hard, logistics. Don't go to QML right now. Do all hands-on experience. Work with these problems is simple. Yes, yes. Thank you. Thanks for your patience. I want to ask you, sorry, in the morning I made you to wait. It is not a good practice. No, due to some other reasons, I was late. So, I am happy to see such a good, we have delivered 20 plus places, but you guys are very extraordinary. Thanks for your cooperation. No, this is 4-year-old. We practiced 4 years, this mathematics and all, but for you it is difficult. Thank you. I want to thank the management. Hospitality is fantastic. I never seen such kind of hospitality. They come to my room. They have taken care in such a way. Whatever I asked, they brought it. Before I started stepping out, they went and collected and came back to the room. So, no, it is a very big thing. No, they have dignity, they are assistant or associate professor. It is not simply taken. Thank you once again. On behalf of Anutantra Private Limited. Thank you.
Thank you very much, sir. So kind of you for your nice words.
No, I told the truth. I didn't pleasing you. That is the truth.
Yeah, even I too believe that, because even one of our colleagues has shared the same, that you praised our participants, that they are very interactive. Actually, I thought of giving that compliment that sir has mentioned. Thank you very much. I understand your sacrifices, your team work, and your travel plans. Everything is hectic. Thank you very much. In spite of some health issues, you are here with us for your time and for your explain in a very simple and understandable way. And as sir suggested, QML, better if it is in the last session, but still computer science teachers can connect. Whereas others from physics and all, I'm not sure, but computer science teachers, it is very good. And one interesting point sir mentioned, Balakrishna sir will be very happy if I say that, that is... Oh, great. We need participants like you who are active and interactive. Sir was mentioning that in quantum, when compared to computer science, other core fields like physics, physicists, chemistry people and other mathematics, all these faculty are doing really very good. So we need to compete with each other and we need to prove ourselves. So I am also doing good. That is the thing. Thank you once again.
And I want to add one more thing. So you people are very lucky. Quantum Valley is in Amaravati only. It is a very huge thing. It is not in Tamil Nadu, it is not in Bangalore, sorry, it is not in Karnataka. So Andhra Pradesh is very lucky. In 2026 they will start the operations.
Yes sir, but I feel that if we want to enter into Quantum Valley, we have to take up the mountain. All the sessions are like not easy going down the valley, but it's like climbing up the mountain. Definitely, whatever news we are seeing in the media, it's very promising. Even for young engineers, next generation students, there will be definitely a huge workforce they are going to create. We shall conclude. Thank you very much once again, Dr. Satyaprakash. Please have some rest. I am somehow bothered about your health. I don't know whether you are feeling discomfort. I'm sorry for it. Please take some rest. By the time Hanumantu will be there to accompany you. Thank you very much. Hanumantu sir, no speaker is telling thanks to me or co-coordinator. They are telling thanks to Hanumantu only. Even yesterday speaker, he is mentioning organizing secretary Hanumantu. So kind of you sir, nice of you. Thank you very much.
Ma'am, he is your representative, ma'am. He is your other face.
Yeah, just we are all colleagues, just kidding sir. Yes. Thank you very much. I invite SKB Venkateshwara garu from SKB College to felicitate our resource person, please. Varma sir, please join for the photograph. Hanumantu sir, so you are the most needed. Please come. Sir, please come.
Yes. Thank you, sir. Thank you so much.
Thank you.
Thank you, ma'am. Thank you, ma'am.
You have delivered very good lecture.
Sir, thank you so much. No, I am interested in with you people. I wanted to deliver this to you people. I don't want to miss this opportunity.
Today morning I am taking class.
Yes, sir.
You are a little bit late, that's why I taken half an hour.